The producers and distributors of Tech AV training programs welcome you to the second module in the series AC and DC Machine Fundamentals. First, we shall overview the three-phase cage induction motor, and you will learn about the key components and their functions, the operating principles of the motor, and basic electrical and mechanical test procedures. The three-phase Squirrel cage induction motor is widely used in industry today to drive a variety of loads because it is simply constructed, cost-effective, and efficient. In its most basic form, the motor consists of the following key parts, namely a rotating part called the rotor, a stationary part called the stator, and two end shields with bearings which support the rotor. Let's discuss the construction and function of each of these parts in detail. We begin with the rotor. A typical cage rotor incorporates the following components, namely a core comprising a number of sheets of high-grade electrical steel called laminations, a squirrel cage configuration of windings consisting of a number of aluminium conductors located in slots in the iron core, two aluminium shorting rings positioned at each end of the core which connect the rotor bars together, and finally the shaft on which the laminated iron core is pressed. One end of the rotor shaft, called the drive end, is used to transmit power to the load. The opposite end of the shaft is called the non-drive end and is generally used to support a cooling fan. We move on to the stator, or static part of the machine. It is composed of a slotted steel laminated core, which is pressed into either an aluminium or iron frame. Three separate windings of insulated copper wire are placed into the slots in a specific pattern, so as to produce the required rotating magnetic field system necessary to turn the rotor. This diagram shows the pole formation of a typical two-pole, three-phase stator. After the break, we will explain the basic operating principles of a three-phase motor.